Hello, good morning friends. Welcome back to your favorite channel Code1 Digest. Today in this tutorial, we will learn synchronous messaging design pattern for microservices. I'll explain what is synchronous messaging design pattern, where to use it, what are the advantages of this design pattern. I will also give you the real world examples of this design pattern. So stay tuned and watch this tutorial till end. It is going to be very exciting and informative tutorial. There is a lot to learn from this video. Friends, in the previous video, I discussed about asynchronous messaging design pattern. Do you know what is asynchronous messaging design pattern all about? Can you explain the asynchronous messaging design pattern? Provide your answer in the comment section of this video. If you have not seen the previous video, so please go and watch that video. The link is provided on your screen and also given in the description section of this video. For more information, go and watch the previous video on Code One Digest channel.
What you need to understand, Susan, is that everyone has an agenda, okay?
Okay friends, so here is the agenda of this tutorial today. I will give you the introduction of synchronous messaging design pattern. What is synchronous messaging design pattern all about? Then we will see what are the challenges or limitations we have with synchronous communication. Then we'll see the real world examples and applications of synchronous messaging, in which project, in which scenario we are using synchronous messaging design pattern. Then we'll understand where to use synchronous messaging design pattern, what all the use cases and usage of this design pattern. Then I'll show you the benefits of synchronous messaging design pattern. At the end, I'll be summarizing this video. So stay tuned and watch this tutorial till end. It is going to be very informative and exciting video. Right, friends? Okay, friends. So let's start with synchronous messaging design pattern. What is synchronous messaging design pattern all about? Let's understand what is synchronous communication. So synchronous communication is the communication when you send a request and you wait for the response to come from the other party. It is a type of a real-time communication. So this design pattern is based on the synchronous communication altogether. This is a type of communication design pattern, and this design pattern is for the inter-service communications. And by end of this tutorial, you will learn how microservices communicate with each other, what is synchronous messaging for the microservice communication, right? So in synchronous communication, one service sends a request to other service and wait for the response before proceeding further. In synchronous microservices, data move to and fro from an endpoint in a blocking interaction manner. Synchronous communication over HTTP using protocols like REST, GraphQL, or gRPC. Synchronous communication is of a type request and response messaging system. Client send request to a service A and service A make calls to service B. Service A waits for the response from service B before sending response back to the client. Right, friends? API gateway is often used in this pattern to receive the request from the client. API gateway then passes the request to the backend service. One thing is important to remember here is synchronous communication forms a tight coupling between the microservices, and any failure in the dependent service would impact the working of the caller service. So we need other patterns to support synchronous communication like aggregator pattern, API gateway pattern, circuit breaker pattern to handle any failures to make our synchronous communication fault tolerant. Right, friends? It always a good practice to have less inter-service communications. But in some cases, we can't avoid the inter-service communication due to customer requirement or the requested operation that need to visit several services for the data. Mostly this happens when the client sends request query to the service, then that service sends request to multiple services to accumulate data for the front-end screen. Example, user wants to see a shopping cart with the product and pricing information. User makes calls to the shopping cart service, and shopping cart service internally makes calls to product and pricing service, right? There are many approaches for implementing synchronous communication, and one of the ways through request response messaging system. So in this case, client sends a HTTP request to a microservice and wait for the response. That microservice calls other dependent services to accumulate data as per the client request. So let's understand this step by step. First, the client sends request to API gateway. Second, API gateway sends request to the shopping cart service. Third, then shopping cart service makes call to the product and pricing service to get data. Finally, shopping cart microservice prepares a response and sends the response back to the client, right? So here, request response messaging forming a tight coupling between these services. That is shopping cart service, product service, and pricing service. If any one of the dependent service goes down, then shopping cart service can't send response back to the client. Shopping cart service will keep calling the dependent service to get the data, as it doesn't have all the data to prepare the response. So shopping cart service will keep trying and keep sending requests to the dependent service. Hence, we have to use circuit breaker pattern to make it fault tolerant and to avoid cascading that failure up to the caller service. If dependency and coupling of the microservice increases, then it creates a lot of issue in the system and loses the power of microservice architecture. So if you have more inter-service communication, then avoid using synchronous messaging pattern. Rather, you should use asynchronous messaging design pattern that we have seen in the previous video. Right, friends? Friends, before we proceed in this video, I request you to subscribe this channel to grow Code One Digest family. Friends, I am creating a lot of quality videos on programming, coding concepts, design pattern and design principles, cloud and container technologies, but I'm not getting subscribers. I request you to like, share and subscribe this channel so that I can grow our Code One Digest family. Thank you. Friends, before we proceed further in this tutorial, let's understand some of the limitation of synchronous communications. It is good to know what are the challenges we have with synchronous communication. Synchronous systems are tightly coupled. That is when the caller service calling a dependent service. So caller service wait for the response from the dependent service. So this may delay and slow down the working of caller service. This is not a good for your design and architecture to handle the requests during the high load situations. In synchronous communication, any problem in dependent service would impact the caller service. Example, service S1 calling service S2 and service S2 calling service S3. So any failure in S3 would cascade back to the service 2 and also to service S1. Hence, it impacts the working of S2 as well as S1. Therefore, we have to use circuit breaker design pattern in synchronous communication to avoid these cascading failures. Right, friends? Addition to the cascading impact, any retry from the caller service would amplify the problem in synchronous communication. As your dependent service is already down or not responding, and our caller service will keep retrying at regular interval, would amplify that problem. Right, friends? So these are some major challenges with synchronous communication that we should remember, right?
What the hell are you talking about?
Okay, friends, so let's understand synchronous messaging design pattern with a real world example. Let's assume we have a e-commerce website and we have a shopping cart scenario where user can see all the items added in the cart with the product information as well as the pricing information. So client want to see the shopping cart page with the product and pricing information. Hence client sends the request to the server. Request comes to the API gateway and then API gateway forward that request to the shopping cart service. On receiving the request in shopping cart service sends the request to product and pricing service to get product and pricing information. Shopping cart service wait for their responses. On receiving response from both the service, it consolidate and prepare the response for the client. Finally, it sends the response back to the user. If you see that example on your screen, the request comes to API gateway and then API gateway forward that request to the shopping cart service. and then shopping as service makes call to product and pricing service, right? And then it has to wait for the response to come from both the service so that it can consolidate and prepare a response for the user. This actually slows down the working of shopping cart service, as well as it's not a good experience for a user, right?
What? I do not understand.
Now let's see another example of synchronous messaging design pattern via trip management service and passenger management service. When passenger requests the site to see all the trip information, the requests come to API gateway, and then API gateway sends the request to the trip management service. Now trip management service makes calls to the passenger service to fetch the passenger data for those respective trips. Hence, trip service is dependent on the passenger service. Trip service have to wait for the response to come from the passenger service. Once the response comes from the passenger service, it prepares the response for the user. Now, this may not be a good and satisfactory experience for the user because it may take several minutes to fetch all the data from multiple services and sends the response back to the user. And then it renders the data on the page for the user. This type of inter-service communication makes your site slow. User won't like to wait longer for the information to come. Hence, these are some limitations with the synchronous communication. Right, friends?
Really?
Now let's see some of the use cases of this design pattern, when to use it, in which scenario we should use synchronous communication. Use synchronous messaging design pattern when you cannot proceed without a response coming from the dependent services. Use this pattern when you want response to come in real time. Use this pattern when it takes less time to commute data and respond. Like when a user wants to log in or user wants to register. In that scenario, you have to respond back immediately to the user, right? Use this pattern when there is no or very less interdependency between the microservices, right? Now let's see some of the advantages of this design pattern. Synchronous communication is simple and intuitive. Synchronous communication happens in real time. This keeps your design simple, and synchronous communication is easy and faster to implement. Despite of these advantages, there are major setbacks for the synchronous communication, like caller service is blocked until the response is received. Server need to be proactively provisioned for the high load situations. There is always a risk of cascading failures. The participating services are tightly coupled, and we would need others pattern to support synchronous communication like chained microservice, aggregator, and circuit breaker design pattern. Right, friends?
Wow.
Okay, friends, now let me summarize what we learned in this tutorial today. I gave you the introduction of synchronous messaging design pattern. Then I explained you the limitations and challenges with synchronous communication. Then I shown you the real world examples of shopping cart and trip management service. Then I explained you when and where to use synchronous messaging design pattern, in which scenario you should use synchronous messaging design pattern. I also explained you the benefits of synchronous design pattern and also the disadvantages of synchronous design pattern. So friends, let me know if you have already used this design pattern in your project or seen a scenario where this design pattern would be useful. Please provide your answer in the comment section of this video.
Oh, wow. That's amazing.
Friends, if you like this video, so give it a thumbs up and subscribe to this channel for the more interesting videos. Click on the bell icon for the latest video notifications, and do not forget to share this video with all your friends and colleagues. This is very useful information for students, beginners, and software engineers. I am putting a lot of efforts in creating these contents, so please help me growing the Code One Digest family. Please subscribe to Code One Digest channel for the latest programming and technology related videos. Thank you.